Hello, Professor. This is going to be a talk through of question 23 from the textbook, chapter 8. And the reason why I picked 23 is because I think 23 is a good way to get a lot of the conceptual parts of this chapter by only having to do minimal calculations kind of at the beginning and one at the end kind of for fun. But a cat's crinkle ball toy has a mass of 15 grams, so let's just convert that as we mark that down. So 0.15 kilograms is our mass, and it is thrown straight up with an initial speed of 3 meters per second. So we're going to say our initial velocity is 3 meters per second. We'll call that VI equals mass equals VI. What is the kinetic energy of the ball as it leaves the hand? So as it leaves the hand, so we remember that kinetic energy equals 1/2 mv squared. When we plug this in, we get 1/2 times 0.015 kilograms times 3 meters per second squared. And when we calculate this equals, remember our significant digits, it's going to equal some kind of joules, so 0.068 joules. That's part A. Part A is a little calculation. A lot of this, most of the subsequent parts of this problem are mostly conceptual. So the next part, how much work is done by the gravitational force during the ball's rise to the peak? So that's where you kind of want to get an idea of what's going on. So there's a little hand right here. There's a little ball. When we throw the ball up, at some point during its peak, it's just going to stop in the air and then come back down. So it has this abundance of kinetic energy. So this kinetic energy right here gets deteriorated by gravity and converted into potential energy as it rises to the top. So part B, once we've done that calculation, is then just a conceptual question. So how much work is done on the ball by the gravitational force during the ball's rise to the peak? The work done by the force is equal to, considering now that our energy is going to go to 0, the work done is how much kinetic energy it took away. So these are the same. Answer C. What is the change in gravitational potential energy of the ball? So the potential energy, starting at the bottom, keep in mind, is 0. And then the question is asking, when it gets up here, what is the potential energy now? So the potential energy is the same. Well, no, it's not the same, but all of the kinetic energy has now been converted into potential energy. So you can just say the same answer. Or, oh, sorry, my mistake on this one right here. Considering the work being done is in the negative direction, down, it's negative. Sorry about that. D. I had that written down. If the gravitational potential energy is taken to be 0 at the point where it leaves your hand, what is the gravitational potential energy, which is the maximum height of D? So this is sort of changing our reference point where we consider the gravitational potential energy is 0. That's the point where it leaves his hand. Again, it's going to be 0.068 joules. Seeing the reference point down here, we marked as 0. So then up here, there's actually going to be potential energy up here, and it stays positive. So E, now, again, we're going to keep the same number. What if the gravitational potential energy is taken to be 0 at the maximum height the ball reaches? What would be the gravitational potential energy when the ball leaves your hand? So this is where kind of we need the change in potential energy to be the same in both cases. So we know the change of potential energy is 0.068 joules. So if we're starting, or if we end up at 0, so we can write this as change in potential energy equals potential energy final minus the initial, P, E, initial. This is going to equal 0. So then we get that the change of potential energy is going to equal the negative of, or we want the initial potential energy is going to equal the negative of the change of potential energy, and we know that to be here, so negative 0.068 joules. And then F is just a fun little kinematics. It's asking what is the maximum height the ball reaches, which you can just do kinematics v, or you could do it a different way. Yeah, let's do it a different way. Let's not use kinematics equation. Let's go the potential energy at the top equals mass, gravity, height, right? The mass we have, so the potential energy we have, so 0.068 joules equals 0.015 kilograms times the force of gravity. So we'll say 9 point, I'm running out of room here, or the acceleration due to gravity, times height. Solve for height. When you do this, let me do this with my calculator, 0.068 divided by 0.015 divided by 9.8. You get the height equals 0.46 meters. Put that over here. F height equals 0.46 meters. Doing that without kinematics. You can use the potential energy formula. All right, and that is all. I hope that was good for you.